Okay, so now find the missing values for each arithmetic or geometric sequence. Underline whether it has a constant difference or constant ratio, and then state the value. So looking here, we go from 5 to 10 and then 10 to 15. I'm increasing by 5. So that is not a common ratio, that's a common difference. So since we're increasing by 5 in the sequence, my common difference is 5. And then to fill in the missing numbers, if I'm at 15 and add 5, I go to 20. And if I go to 30 and I add 5, I'm at 35. So what I'm going to do now is model this with an explicit equation to take it a step further. So for the explicit equation, I'm going to start with the first term. So I'm going to write it in the form y equals a sub 1 plus my common difference, and then I put times n minus 1. So substituting, the first term is 5. So y is equal to 5 plus, my common difference is 5, times n minus 1. And then again, this is an arithmetic sequence because I have a common difference of 5. Moving on now, I'm now going to model number 2. So I'm going from 20 to 10, and it's tempting to just say, well, I have a common difference of 10. Well, my next number here, if I subtracted 10, I would go 10 minus 10 is 0. Well, then I couldn't go back up to 2.5, so that doesn't make sense. So this is not an arithmetic series. That means this is geometric. So we have to figure out, well, what is the common difference here? So I'm going to start, or the common ratio. Sorry, I misspoke. So we have a sub 1 and then a sub 2. Well, you take the second number in the series to find that ratio and divide by the number before it. So what we can say here is r is equal to a sub 2 divided by a sub 1, or 10 divided by 20, and then that gives us 0.5. So my common ratio is 0.5. So then to fill in my missing numbers, I can go 10 times 0.5, or half of 10. I know that that's going to be 5. Well, half of 5 is 2.5. And then here to go 2.5 times 0.5, I'm going to model that with the calculator. That gives me 1.25. And then I'm going to write an explicit formula. Again, it helps if you write that down every time. So for an explicit formula, I'm going to write y is equal to a sub 0 times r to the nth power. Well, we have the first term is 20, so I have to work backwards. If I'm timesing by 0.5, to move to the right of the sequence, I do the opposite and divide by 0.5. So to get a sub 0, I'm going to take a sub 1 divided by the common ratio. So 20 divided by 0.5, and I got 40. So y is equal to 20, or I'm sorry, my a sub 0 is 40 times my ratio is 0.5 to the n. And then once you have an equation, it helps to just check. My third term should be 5. So I'm just going to substitute 40 times 0.5 to the third and see if that does in fact give me back 5. And I do get 5.